Hello everyone. In this video, I would like to go over the product rule for differentiation. The formulas for the product rule works like this. So if you have two functions multiply with each other, and you have to take the derivative of that as a function of x. So what you need to do, you need to identify your function u, then identify your function v, and fit them into these formulas right here. So you have to differentiate function u in terms of x, then differentiate function v in terms of x. I strongly recommend that everyone will identify the very first function here as the u and the second function as the v. So I always try to put them in this order. U comes first and then the v. Even though it doesn't matter with u and v, because the formulas here indicated that is a addition. All right. So, but to be consistent and to avoid unwanted error, I just want to be consistent in this case, and I will identify 6 plus 7x, all of it to the exponent 2 as u, and then I identify 3x minus 2, all of it to the exponent 3 as v. First of all, I encountered this question while I was teaching the course years ago. So my student asked me that, do I have to work with the product rule? So my answer for the student is this. So the product rule, or this definition of this formula, invented for a reason. It means that mathematicians, they only make up these formulas, or they can invent this formula so that it can simplify the mathematics. So nothing in mathematics is created to make it more complicated to anyone. Okay, so if you want to go with that route, that you just want to expand this, and then you differentiate each term individually, and then at the end you factor them. So I can tell you that it's actually even more tedious and more complicated. So if the product rule is given to us and is there for us to use, then we should apply the product rule. All right. So I will identify u as 6 minus 7x, all of it square. Okay. Immediately after this, I want to take derivative of u as a function of x. So again, we have done the basic derivative in previous video. So we have a function raised to the power, so you have to apply chain rule. All right. So I take 2, I multiply the 1 in front of this bracket. I should have 2. Inside this, I should still have 6 minus 7x, but this will be to the exponent 2 minus 1, so that should be a 1. And apply chain rules. Then I have derivative of 6 as 0. Derivative of negative 7x is equal to negative 7. Okay. So let's leave this for now, and I go back to that in a minute. And the next step is I will identify the v. So v is equal to 3x minus 2, all of it to the exponent 3. Then I will take derivative of v as a function of x. Then I have 3 times 3x minus 2, 3 minus 1, so I should have 2 left. And chain rule, it means that I need to take derivative of 3x minus 2, and derivative of 3x minus 2 is 3 minus 0. All right. So I would like everyone to take a look at your coefficients here. So here you have the 2, here you have the negative 7, okay, for du over dx. For dv over dx, you have 3 and 3. So among 2, negative 7, 3 and 3, you don't see any common factor here. So the next step is you can multiply this together. So I will write negative 14 times 6 minus 7x. And this one I will write it as 9 times 3x minus 2, all of it to the exponent 2. The reason I ask everyone to pause and then check if you, among all of this coefficient, if you have any common factors, then you don't have to multiply them or write the product as a coefficient for this entire binomials. Because you don't have any common factors, so you can go ahead and multiply them. Okay, because in fitting all of this into the formulas that you have to perform as a product rule, in the end you have to simplify your answer anyway. So simplifying your answer means you have to factor out the common factor. So you don't want to multiply and then factor again. Alright, so in this case, I multiply them because I know that negative 14 and 9, they don't have any common factors. Okay, so now we can go ahead and fit this into our famous product rule formulas. So then the next step is writing dy over dx. I would like everyone to be a bit mindful of your notation and how you present your answer. So I put dy over dx because I am telling everyone that I differentiate my functions right now, right? So I differentiate my function. These are the products of two binomials. So I am going to apply this product rule. So please write dy over dx, and then I fit this into my formulas. So u will be 6 minus 7x, all of it squared. Okay, multiplied by derivative of v as a function of x. So I will write 9, and I multiply that with 3x minus 2, all of it to the exponent 2. And then I add that with v, which is 3x minus 2, all of it to the exponent 3. And then multiply by derivative of u as a function of x. So I multiply by negative 14. Make sure you put negative 14 in the brackets because you want to say that you are multiplying by negative 14 times 6 minus 7x. Okay, so let's double check. So here's my u, right? Okay, so dv over dx, this is v, and du over dx. And it's fit right into this product rule formulas. So the next step, I found that might pose a bit of the challenge to quite a few students because we need to really master the algebra. So I was slowly going over the concept of factoring. Okay. But before I explain this into detail, I will ask everyone to recognize that when you factor out the common factor, you can factor out a binomial as well. It's not that you just factor out like one term or one numbers. You have to realize that you have to factor out a binomial raised to certain power. Okay, so I will highlight the one that actually has a common factor. So this expression that I have, and also this one are my the expression that I know that I have a common factor among these two. So you have 6 minus 7x all of it to exponent 2, and you have 6 minus 7x raised to exponent 1. So to factor, what you do is you will factor out the 1 with the lower exponent. Okay, so I will take this one out of the bracket. So let's see what I have inside the bracket now. Okay, so inside the bracket, I know that this one will be gone. Okay, so this one right here, you won't see that anymore because you already brought it out of the bracket. But in this whole expression, you will have the 6 minus 7x left over. Okay, so I will write it's in green because it's the whatever left inside the bracket because of the green box that I highlight for this 2. 6 minus 7x. Okay, so that will raise to the exponent 1, right? Okay, so because what you do is you take this, multiply them back, is you have like a square. And your next common factor is 3x minus 2. Okay, so the trick here is you are going to pick the binomial with the lower exponent. So I will pick 3x minus 2, all of it to the exponent 2. Okay, so if I pick this one, then it means that I will have no more 3x minus 2 to the exponent square next to this term. So the only number remaining would be a 9. So I will write a 9. Now I have to add that with. So you see that I will have negative 14 left in here. And 6 minus 7x is already outside the bracket. So what I have left inside this bracket would be 3x minus 2. Okay, raised to the exponent 1. So now what we are going to do next is we just have to expand what we have inside the bracket, and then we excuse me, then we can collect the like term. I'm sorry, I have a bit of a pause because of my throat, and I actually get just drank a bit of tea here. So if you kind of feel that I have to pause, then because I need to take a sip of tea because of the throat. Okay, so now in this case, you see I will have 54 minus 63x. I will have negative 42x plus 28. Okay, so just a basic expansion. Multiply this 9 into each term into this bracket. So distribute the term here, distribute the terms here, and then now I can collect the like term. So collect the like term. I should have this left inside the bracket. I should have 82, okay, and subtracted 105x, and that the whole thing is simplified. All right, okay, so double check one more time. 6 minus 7x, 3x minus 2, all of it square, and 82 minus 105. All right, so I know that you still have quite a question to ask me, and in teaching using video, I don't think I can directly answer the question for you. So I actually kind of guess that you probably asked me, how do I get this factoring here in this line? How do I take 6 minus 7x out as a common factor? Inside I have this left, and how I take 3x minus 2 outside of the brackets as my common factor, and inside I just have this left. Okay, so I would like to spend the next few minutes to explain to everyone the behind the scene of the factoring. Okay, so the process of factoring, because you have done factoring for a long time, and then we do that automatically. And sometimes we forget why we have to do it that way. Okay, so let me start with a very simple expression, which everyone recognize very easily how to factor. So let's say I have 10x squared minus 5x. Okay, so 10x squared minus 5x. I ask you to factor this. So I will say factor this. So then you say, oh, Professor Huang is so easy, so simple. It will be 2x minus 1. Okay, so I will do that for everyone. So it will be 2x minus 1 by taking the common factor of 5x outside the bracket, right? Okay, so because when you did this, you actually immediately checking if 5 times 2 is 10x squared, and then x times x is x squared, and then 5x times minus 1 is 5x. Okay, so what is the step behind this common factoring? The step behind this common factoring is this. Okay, so this is very important, and I hope this is not the first time that everyone learn about factoring or hear about why when we factor we in fact doing this step. So if I have 5x as a common factors, Okay, it means that you multiply this whole expression that you have right here. Okay, you multiply this whole expression with 5x. So if you multiply by, in order for you to get back to your original statement, you have to divide it by. So it means I in fact divide this 10x squared by 5x. Okay, I do the same here. I take 5x divided by 5x. And I simplify what I see inside the bracket. Simplify what I see inside the bracket. You see this 10, that will be 2, right? So x squared divided by x is just x, and that, cancel that. 5x divided by 5x, I just have 1. So basically, then I end up with 5x up 2x minus 1. Okay, so can I repeat myself? Your common factor, if you pull it outside this bracket, it means that you need to divide your common factor into each of these terms inside your bracket. And then we go from there. That's the behind the scene of common factor. Okay, so I am saying this because I will perform that step to show you why I end up with this line. All right, so let me make this as, so in this green box, okay, I am going to take out the common factors. At the same time, what I do is I will show you why I have this left. Okay, so basically what we have is I am pull out 6 minus 7x, and then I pull out 3x minus 2 as my common factor, because I was telling everyone that between these two, okay, so you have 6 minus 7x squared, then you have 6 minus 7x to the exponent 1. You always take out of the bracket the binomial with the lower exponent. So the lower exponent, this one, in this case 1. And you have 3x minus 2, all of it square. You have 3x minus 2, all of it to exponent 3. The one with the lower exponent is 3x minus 2. Okay, so then what do I have originally inside the brackets? I have this. I have 6 minus 7x square times 9 times 3x minus 2 square. Okay, so the concept behind common factor, that I need to divide my common factor into each term. Okay, so that's what I did. Okay, I divide into each term is here. So what is my next one? My next one is 3x minus 2, all of it square, and then times negative 14, and then time that with the 6 minus 7x. Okay, then I need to divide my common factor into each of this as well. Okay, so it's tedious, but if we do step by step, now that I can explain to everyone why I end up with the simplified version inside the bracket. So now you see inside here, that cancel with that, okay, because they are exact same, and that cancel with that. Okay, so let's rewrite what we have. We have 6 minus 7x, and I have 3x minus 2 all of it square. Okay, so take a look at your very first expression here. Okay, your very first quotient here. So you have a square right there. Is that right? And then you have 1. So you are dividing two powers with the same base. So that means you have 1 left. 2 minus 1, so you have 1 left. So that is why I have 6 minus 7x to the exponent 1 left. So in the way that you take 2, you cancel with this right there. Okay, and then I still have to multiply by 9. Okay, for the second one, I still have negative 14 left. But what do I have left now? So this should be to the exponent 3. Yes, this should be to the exponent 3. It should be a 3. Okay, so 3, and I simplify with the 1 at the bottom. See, that and that cancel out. So that's why I have 3x minus 2 left. inside the bracket, as I have explained above for everyone. Okay, so just make sure that you note this. Okay, so just keep in mind that's the process of common factoring. All right, I would like to continue with the next question. It's also the product rules in this case, and I will apply the exact concept of factoring. All right, okay. So for this question, I will identify u as 2x minus 1 raised to the exponent 1/3. Okay, you need the exponent to work with. So then du over dx will be 1/3, and then 2x minus 1, 1/3 minus 1 will be minus 2/3. Okay, and then derivative of 2x minus 1 is just 2. So don't forget that you need the to apply the chain rule in this case. Okay, so again, like I told everyone, I leave it all of this factor for now, and then I start with the v. So v will be x to the exponent 1/2. So dv over dx will be 1/2 times x to the negative 1/2. Okay, 1/2 minus 1 is negative 1/2. So now I check 1/3, 2 and 1/2. They are not having any common factors among themselves. So this one you can go ahead and write this as 2 over 3. Okay, so 2 over 3 of 2x minus 1, all of it to the negative 2/3. Okay, so let's put it into our formulas. So dy over dx equal to, so again, make sure that you write dy over dx because you're telling your professor that you're going to differentiate now by fitting all of this into your product rule formulas, right? So the u will be 2x minus 1, all of it to the exponent 1/3. V is 1/2, and then x to the negative 1/2. So let me make sure that I write it properly so we are not mistaken with negative 1/2, but that is 1/2. So let's check. This is u. This is dv over dx. So we are good. And the next step is to write v. So I will have x to the 1/2, right? X to the exponent 1/2. And then I can multiply that with 2 over 3. Multiply 2x minus 1, all of it to the negative 2/3. Okay, so the next step is to factor. Okay, so how do we factor this? So go back to the idea of factoring that I have shown everyone above here. Okay, so when you do a common factors, you actually divide your common factor into each of your expression inside the bracket. So first of all, if I have 2x minus 1 to the 1/3, and I have 2x minus 1 to the negative 2/3, so ask yourself this question: 1/3 and negative 2/3, which exponent is smaller? Obviously, it's a negative 2/3. So then your common factor in this case will be 2x minus 1, all of it to the exponent negative 2/3. Okay? And your next common factor should be x to the negative 1/2 and x to the 1/2. So which one is smaller? Okay, which one has the smaller exponent? Is the x to the negative 1/2. Okay, so then I will take out the x to the negative 1/2. So that will be my next common factor. Okay, so let me write it here for everyone. So I just want to be consistent here. So this is v. Okay, this is v, and this next one would be my du over dx, just to make sure that I fit them into. I just want to be consistent with my writing on here for everyone. All right, okay. So I want to take this out, and just to make sure that we check that everything is doing just fine. Now, so inside the bracket, okay, inside the bracket, here's what I have to write. I just want to prepare the step ahead. So it means that my 2x minus 1 to the negative 2/3 times x to the negative 1/2 will have to be divided into each term inside the bracket. Okay, so then on top, what I have is 2x minus 1 to the 1/3 times 1/2 x to the negative 1/2. Okay, so for this term, you see that and that cancel out. Okay, and if you take this part here, okay, so this here and that, isn't that should be 2x minus 1 of 1/3 subtract negative 2/3. Okay, so in this case, you will end up with 2x minus 1 to the exponent 1. Okay, so the next, don't forget you still have the 1/2 left. Okay, so, but I will write that in later. So for this second part, here I should have x to the 1/2, and then I have 2/3, and I have 2x minus 1, all of it to the negative 2/3. So obviously, this one and this one cancel out. Okay, so the 2/3 still left over, but now you see that you are having x to the 1/2. Okay, subtract the negative 1/2. So then you have x to the exponent 2/2, which is x to the exponent 1. Okay, so let's write what we have inside the bracket in here. So dy over dx equal to 2x minus 1 to the negative 2/3 times x to the negative 1/2. Okay, inside the bracket, I left with 1/2 times 2x minus 1, and then I should have 2/3 times x, right? Okay, very good. So what you do next is you go expand. Okay, you distribute the term inside the bracket and just leave your negative exponent here for now, and then we will worry about turn that into positive exponent in a minute. Okay, so when I take 1/2 times 2x, you see that I just have x left. Okay, then I have negative 1/2, and then I plus is 2/3 of x in this case. So to simplify, I will write dy over dx equal to 2x minus 1 all the way to the negative 2/3 x to the negative 1/2. Inside the brackets, I should have I will combine this two, so I should have 5/3x. Okay, so 5/3x minus 1/2. Okay, so let me show everyone how to simplify all of this. What you can do in this case is, now you should bring this 2 down to the denominator. Okay, so this should be in the denominator. I should have 2x minus 1, all of it to the 2/3, and x to the 1/2. Okay, because you bring it down to the denominator, you can take away the negative sign. So for this top part here, I want to take the common denominator of 6. Okay, so then I should have 10x minus 3, all of it divided by 6. All right, okay, so this is like 10x minus 3, all of it over 6. So what you are doing now is you can rewrite this as just a fraction. So 10x minus 3, everything, divided by 6, x to the 1/2, and then 2x minus 1 to the negative 2/3 as my final answer. All right.